All right, Algebra 2, we're talking about Chapter 10, Section 2, Parabolas. We want to start with a basic definition of how you even create a parabola. So there is, anytime you have a line called a directrix and a focus, which is a point, you can create a parabola. So it really only takes a line and a point. Now, this point and this line are not actually a part of the parabola, but they are used in actually creating the parabola. So let's just see how this works. We need every point that we can find that have the same distance between that point in the focus and that point in the directrix. So let me find the first one. Right there is the first one. It has the same distance here as it does to here. So that is one of the points on our parabola. In fact, that particular point is kind of important. We call that point the vertex of the parabola. It is the point where the parabola changes directions. Now, I will tell you that this is a point also on my parabola. How do I know that? Because the distance to the focus is the same as the distance to the directrix. This is a point also on my parabola, because the distance to the focus is the same as the distance to the directrix, or approximately. I think it's a little bit far. Probably more like there. That looks better. Every point that you can find where the distance here is the same as the distance here creates this shape called a parabola. So the focus and the directrix are very important to that. Now, the distance from the vertex to the focus and the distance to the directrix is called c. We use the letter c to represent this distance, which is also the same as this distance. So the letter c for both of those. And you'll see how that plays a part in the equation and all that good stuff here in a minute. There are a couple different types of parabolas that we are going to be dealing with. You are very much used to dealing with this one over here. We talked about that in Chapter 5, y equals ax squared, where in this case, a is a positive number, right? A is greater than 0. We've also dealt with the upside down version where a is less than 0. Still y equals ax squared, but a is less than 0. The ones that we haven't talked about are the other variety where x and y are switched. If you switch x and y, yes, we're talking about an inverse, right? Because when you switch x and y, that's what happens. You get an inverse. This is the left and right opening variety. So we have the up or down opening one over here, and we have the left or right one. Of course, this is a is greater than 0, the positive direction. And when it goes to the left, that would be you're less than 0. Still the same equation. Oh, one other piece of information I want to just tell you or remind you of. The focus is always inside the parabola, and the directrix is always on the outside of the parabola. Focus is always inside, directrix is always outside. So in every one of these situations, there'll be a focus and a directrix, which remember are not really part of the parabola, but they are important in finding the definition of that parabola. So every one of these has a focus inside and a directrix outside. Now, if you can tell, this would be a horizontal line, y equals a number, and these would be a vertical line, y equals another number, or x equals a number. So we have to draw the pictures. That's extremely important. So in example 1, it says find the equation of the parabola that has focus 0, 3 and Directrix y equals -3. And my first piece of advice is always draw a picture. So 0, 3, and y equals -3. And I'm going to do a dashed line just so that we understand that it's not a part of the actual parabola. Now the vertex would be in the middle between those. So that happens to be 0, 0. How convenient. Now what's this distance that we called c? C was equal to 3. Now, you know what? I just realized I need to back up. I had a couple equations on here previously at the bottom of the last screen that you might have copied down, but you didn't understand. So let me go back and look at those and explain those. These right here are explanations of how A and C work together. Now, if you look closely, you can probably tell that we just cross-multiplied in order to alter what these formulas look like so you can see whether it's solved for A or solved for C. That's all we were doing is cross-multiplying to come up with those values. Sometimes it's more useful to use one or the other. For instance, in this next example that we're doing, I think I'm going to use this one because I know that the value of C is 3 and I can plug it in. So let me go back to that example. So we've drawn our picture, we've identified what C is. C is equal to 3. Okay? Okay, I'm losing my mind, I think. So, no, I think I am not losing my mind. Okay, something's wrong with these boxes. All right, I'll have to get that fixed later. Anyway, so I need to try to figure out what the absolute value of A is. Remember that C is equal to 3, so I plug it into the equation. And we find out that it is 1/12. Now, the big question is, I know this thing opens up. So, is that y equals ax squared or x equals ay squared? Well, this is actually the y equals ax squared variety of the pictures that we looked at before. So I know that when I get done, I'm going to have something times x squared. The big question I have is A equal to 1/12 or -1/12? Now, how am I going to know whether it's positive or negative? By looking at the picture. The picture is showing me that it goes up, therefore it is positive. So I now have my equation. Drawing the picture is rather important. Let's look at example 2. Write the equation of the parabola with vertex at the origin, okay, and focus at -5, 0. Well, that must mean at 1, 2, 3, 4, 5, my directrix is sitting over here, and that would be x equals +5 is my directrix. We know that this thing opens to the left, so it is of the variety x equals ay squared, because it opens left or right, but in this case it's opening left. The distance C is equal to 5 units, right, counting from the vertex to the focus or from the vertex to the directrix. So we can use our formula, absolute value of A is 1/4 times C. So we know it's either, 1/20 or -1/20. Because we are seeing in the picture that it opens to the left, that would be a -1/20. So just because you use the formula to find the absolute value of A, you still have to make a decision whether it's going to be positive or negative. And that comes from looking at the picture. Example 3 says write an equation of a parabola opening left with vertex at 0, 0 and focus 6 units from the vertex. Well, 6 units from the vertex, we have to go inside the parabola to find the focus. So C is equal to 6 units. The absolute value of A would be 1 over 4 times 6, or 1 over 24. We know that because it opens left, it's x equals something times y squared. So the question is it positive 1 over 24 or negative 1 over 24? And the answer comes from the fact that it opens to the left, negative 1 over 24. Identify the focus and directrix of the graph of the equation y equals negative 1/16 x squared. Okay, so I'm just going to draw a quick little picture here. We know that this is a up and down variety, and because that's negative, we know that it opens down. It is centered at the origin because there's nothing being added to x before it's squared, and there's nothing being added out here. So we know that it's 0 for h and 0 for k. So we know that once we find our distance c, we're going to be going down to find the focus and up to find the directrix. Well, let's see. C is equal to the 1 over 4 times the absolute value of A, negative 1 over 16. Well, that's 1 over 4 times 1/16, which is 1 over 4 times 1/16 is 1/4, and 1/4 goes into a dollar 4 times. So C is equal to the number 4. Sorry, it's off screen. I'll make sure you can see it. So 4 units inside here would be what coordinate? The focus would be at 0, negative 4. And the directrix would be a line 4 units above. That is the line y equals positive 4. So there's the information they wanted to know about directrix and focus. All I had to do was find the distance called C. Identify, example 5, identify the vertex. This one's a little bit more